So question 21 is quite troublesome because they give three statements and then we are going to prove whether it is true. The problem is really difficult to find out. For example, if I do not find any method to prove this one, but maybe this one is correct. So sometimes it's really difficult to prove it is wrong. But anyway, to solve this question, you need to know very clearly about basic trigonometry involving right angle triangle. So it's most probably not related to sine formula or cosine formula, just what you learn in form 1. Junior form. So in this case, very important thing is this is 90°. And read the question carefully. They tell you that this is separated to 3 equal parts. And then if we look at the first one, AF is not equal to sine alpha, right? It should be equal, it should be related to beta, right? So this statement is not easy to prove. We have to change something first. If just simply think it is correct, then what will happen? Then we can compare AF over sine beta with beta, and then compare BE with sine alpha. So it's makes sense now. For beta, we are comparing AF and beta. For BE, we are comparing BE with alpha. So then we can brainstorm what will happen next. So if we consider AF and then we want to compare with sine beta, so of course we will compare with this line. So AF compare with DF is equal to cosine beta. Okay, and then at this moment, it's totally not related to sine ratio, right? It's just related to cosine ratio, right? So this kind of method do not help us to solve the problem. Then we may need to think another method to solve the problem. If we can't compare beta together with AF, then maybe we use another approach. We compare AF with BE. And don't forget that AF 2 units and BE 2 units. So basically they are the same. So this is 1. That means if the statement 1 is correct, then sine alpha will equal to sine beta. The only possibility is alpha equal to beta in this situation. But however, this line is obviously smaller than this line. So we know that sine beta should be smaller than sine alpha, which contradicts with the condition. So the first statement is wrong. Of course, it's difficult. It's because you need to brainstorm a lot of implication from the assumption and then see whether it is correct. It's really difficult to prove that it must be wrong. But if you can do so in this question, if you prove that 1 must be wrong, then you can exclude A, B, and D. That means your answer must be C here. But of course, there is some method for you to prove the second statement and the first statement. I'm going to continue. So if we continue, we consider the second one. We use the logic that we used just now. CE compare with cosine alpha. So you need to have a very strong sense in right angle trigonometry. This is CE, this is alpha. Then this is CE times cosine alpha. This one is CE times sine alpha. But this one is not needed, so we just focus on this part. So this is E to B. Afterwards, similar thing about DF, we focus on this right angle triangle. This is df, and then this is cosine beta. I mean, this is beta. So this line is df cosine beta. This is df sine beta. If you ask me how can I remember, first cosine is smaller than 1. So from the longest length, we can get a shorter length by multiplication. This line is related to adjacent, so it's related to cosine. This line is opposite of the beta, so this is sine beta. That's how I get it directly, and this technique is quite useful in physics also. So go back to this question. So this is AF. So we know DF cosine beta is equal to AF, and at the same time, just like what we mentioned, AF and BE are the same, equal to BE. That means equal to CE cosine alpha. So the second statement is correct. Then how about the last statement? It's about AD tangent alpha. AD alpha, they are not from the same triangle, so it's meaningless to consider them together. So we consider if AD tangent alpha is equal to BC. Before we prove that, we try to tidy up. AD compare with tangent beta. We want to compare AD with beta. BC we compare with tangent alpha. See what is this. So focus on this part first. Between AD and beta, this is AD, this is beta, so we use AF to represent it. Or you may consider it is 2. This is 1, 1, 1. You may consider it's 2. It do not affect the answer. So AD divided by AF is equal to tangent beta. We want what we have here, so that's why we rearrange the position. AD divided by tangent beta is equal to AF. So some of you may understand what I'm going to do now. Another part, we are going to do similar thing. So this is BC, and then this is alpha. To compare tangent alpha, we need to compare these two lines. We need to compare EB, that means 2 here. So BC divided by EB is equal to tangent alpha. BC tangent alpha is equal to EB. So just now, it's not exactly 1. I just mean that this is 1 unit. So this is 2K, this is 2K. And then, so these two basically are the same, which means if you rearrange them, this one is correct. So both the second one and the third one is correct. Sometimes it's not easy for you to think how can you exclude the possibility of 1. So that's why this question is defined as difficult question.